Welcome to this presentation about an FRG Micro Grant that was recently given to the University of Canterbury. The title of the project is Fire Spread on Plastic Fuels at Different Inclinations, and the project leader is Andres Valencia. Andres is a lecturer of Civil and Natural Resources Engineering at the University of Canterbury. His research interests include analysis of sprinkler systems, which include both experimental as well as numerical analysis, but he's also interested in fire dynamics and wildfires. Andres, could you please tell us more about this exciting new project?
Hello, Daniel. Thank you very much for the introduction, and I would like to thank also Fire Research Group for their support and all the people that are actually following the webinar. During the next 5 minutes, I'm going to present the project we will be working in during the next year. We will be mainly working on the fire spread phenomena on a flat surface. So it's basically the progression of a fire on a flat surface. Now, this is a widely studied phenomena in fire science, and it's basically because it's also very common and we can find it in very different fire scenarios. Now, we are particularly interested in the influence of the inclination of this surface on the global, let's say, behavior of the fire. For example, we are interested in how fast the fire is going to spread if we change the inclination of the surface. Also, what will be the change of the energy production when we change this configuration. Now, I have prepared for you some images showing, let's say, the context and also the relevance of this research. So here we have the CCTV building fire in these two images here some years ago in China. This fire reached the cladding of the building, and as you can see, this exterior geometry of the building was kind of complex. For example, we can imagine a fire progressing as a wall fire in this surface, while we can imagine another type of fire evolving as a inclined fire here. So we can see that in the same building we can have different configuration of fires and having different surface inclinations. Another interesting phenomena, let's say interesting example, is solar panel fires. So for efficiency purposes, those devices are actually installed in an inclined configuration. Now, for example, if we have if there is a electrical failure, a fire can start, and in some cases, the fire can also progress along the surface of those devices, producing an inclined fire. Now, what is interesting from this case is that previous research have shown that the inclination of the fire can completely change the dynamic of the fire. For example, this beautiful experiment from Wang and some of the colleagues shows how at different inclination we can have a different fire. When I say different fire, I'm talking about completely different characteristics. For example, from a combustion perspective, you can see how this fire here at 90 degrees is kind of yellow, while this one is blue, showing a different chemistry and different combustion happening. Now, in general, for example, we can also see that for the wall fire, we have what I will call a boundary layer fire, in which we have this small thickness, and we have a lot of different changes in temperature and concentration going on there. Here we have, for example, what depending on the material, but we can say that this one is very close to a pool fire, while this one is closer to a ceiling fire. So you can see how the dynamic, the structure, and the behavior of the fire can actually change dramatically if we change the inclination of the surface. Now, our approach is to use three techniques to study this phenomena. The first one is, so what would you see here, this one is a PMMA material that we will be using during the experiment. This is just the structure, is a inert material. Now, our first technique will be to use thermocouples. Our plan is to embed the thermocouples inside the material, just at the surface level of the material, in order to follow the progression of the fire and also, the progression of the combustion. Now, the idea is to do a grid of thermocouples, about 25, to also study the progression to the let's say spatial configuration. Now, our second technique is this heat flux gauge, which will help us to study the fire feedback, heat flux feedback from the fire to the surface. And finally, we will be also using some oxygen depletion and mass loss rate techniques to study the change on, let's say, the production of energy through the progression of the fire. We will study three main cases: 45 degrees, 90 degrees, and 135 degrees. And the idea is to only study these three, see how it goes, and if we see that the experiment is going well, we will explore more cases. So this is a general view of our project. I hope that you enjoy it, and probably you will see me again during the next year showing you some of the progress and some of the achievement of this work. Okay, so thank you very much for your attention, and see you next year.